have been doing problems based on the work done, that is different applications of the same work done concept for different situations. And in this problem what we are going to discuss now, situation is given and it is on work done. Let us see how we should analyze the given situation or the problem and apply it in the standard equation. So, come here, let me read it, listen carefully. An object of mass 2 kg is thrown up from the ground and reaches a height of 5 meters and falls back to the earth. Air resistance is neglected. Calculate 3 situations are given. First one, work done by gravity when the object reaches 5 meter height. Work done by gravity when the object comes back to earth. Third, the total work done by gravity both in upward and downward motion, and mention the physical significance of the result. Now, what is the situation here? Let us see, mass is given, okay, on 2 kg is thrown up. Here the situation is this 2 kg mass is thrown up, and anything that is thrown after reaching a particular height will come back to earth. That is what it says, from the ground and reaches a height of 5 meters, and it comes back to earth, and we are asked to neglect the air resistance. So, we need not bother about the influence of air resistance in this situation. So, if I have to diagrammatically understand, so some mass say 2 kg is thrown from this level, ground level. So, when it is thrown, it goes here, and this is the initial position, and it reaches this final position, and the displacement here is 5 meter, because it is reaching 5 meters height. So, it is reaching from here to here. So, the direction of motion is in this, that is, it is thrown upwards. So, upward is the direction, and then after reaching this height 5 meter, the same thing falls down. So, it reaches particular height and it comes down. Now, the object reaches the ground, and in this case this downward it falls. So, this is upward and this is downward, and this becomes the initial position, and this is the final position. But this is also 5 meters, because it comes from the same height, 5 meters. So, now in both the cases what is asked? Work done by gravity. What is the work done by gravity during its upward motion? What is the work done by gravity during its downward motion? And so, the total motion is upward, downward. So, third question is total work done. So, now let us apply the formula. What is the formula? Work done is equal to F cos theta dr. So, in this case, F cos theta I am taking out, gravitational force, which is constant force, I am taking it out, and if I say integrate it between this and this, it is going to be equal to, when we integrate, it can be replaced like this, between RF and Ri. So, RF and Ri, the distance, that is your displacement. So, I can also write directly as displacement dr. So, the same formula F cos theta dr. So, let me apply the first situation, upward. Who is doing the work? Gravitational force only. So, gravitational force during the work done by the gravitational force during the upward motion, what is F? F is mg. So, the object is moving upward, but still the gravitational force will be pointing towards the ground, that is mg downwards. and therefore F is equal to mg. So, in this case the force is gravitational, so which is mg. And then cos of the angle. What is theta? Theta is the angle between the direction of the force and the direction of displacement. What is the direction of the force? Direction of the force is pulling it down. What is the direction of the displacement? Moving it up. It is moving up. So, theta is the angle between the upward and the downward, and therefore, theta in this particular case is equal to 180 degrees, and therefore, cos 180 is equal to minus 1. And what is the dr? So, dr in this case is 5 meters. Initial and the final distance is 5 meters. So, let us substitute work done during upward motion is equal to m, his mass is given as 2 kg, g is given as 10 mg, cos of the angle is minus 1 and the displacement is 5. And therefore, the work done during the upward motion by the gravity is equal to minus 100 joules. So, let us go to the second situation. What is the second problem? What is the work done during its downward motion? So, the downward motion, what difference does it make? Again, the gravitational force is only going to act on it, and it is going to travel the same distance of 5 meter. The difference is theta. So, in this case, the object is moving downward and the gravitational force is also downward, and therefore, in this case the formula is same thing, mg cos theta into the displacement dr, but theta in this case is 0 degrees because both are in the same direction, force and the displacement, and therefore, cos of the 0 is plus 1. So, come again, substitute. So, downward work done is equal to same object traveling through the same displacement, and so m into g, only thing is it is plus 1 multiplied by 5. So, what is the answer? Plus 100 joules. So, upward minus downward plus 100 joules. Now, read the third answer. Total work done by gravity both in upward and downward. So, total will be sum of the two, that is total is equal to upward plus downward, which is equal to minus 100 joule plus 100 joule, which is 0. And therefore, when the object goes to a particular height and comes back and falls on the ground, the total work done is going to be 0. Now, you carefully see, you are asked to give the physical significance of the result. So, what does it convey to us? What physics it talks to us? It simply says, when the object moves upward, some energy is transferred because work is done against the direction of the force. Though mg pulls it down, it goes up. And therefore, some energy is given to the object by the external source. The external source could be someone who throws or something which makes it move upward. So, during the upward motion, energy is transferred to the object. But during the downward motion, where it comes through the same distance and reaches the ground, energy is transferred by the object to the surface of the earth and it dissipates. And therefore, this is the energy is given to the object and the object comes back and transfers the energy to the surface of the earth. This is what is the physics that we learn by looking at this answer, positive and negative of equal magnitude, and therefore work done is 0.